Alright, so I told you that I would show you a little bit about the um, time travel curve, or the travel time curve for finding an earthquake, and so I'm going to show you that right now. But the first thing I wanted to show you was the seismic graph, the records and what they actually look like. So this is a picture of a seismic graph that you see here of 3 different places. So we have one for Sitka and Charlotte and Honolulu, and it doesn't matter. These can be all over the globe, and we can actually get information from each one of those, because the S wave and the P wave, they are body waves, and they can actually travel through the Earth. Now, you'll notice on this you have the times down here at the bottom. So we have 8:06. 8:08, 8:10, 8:12, 8:14, 8:16, and these are in minutes. And each blue line here, in this case, represents 1 minute. So this would be 8:06, 8:07, 8:08. And what we want to do is we want to look at when the earthquakes actually hit, like Sitka here. So we know that the P wave is the fastest of them. So what we end up doing is we come right here to this point where we see that first jump. And we're going to put a mark right there, and we want to make sure that we are parallel with these lines here. And we're going to just draw a straight line down, parallel or perpendicular down here. Okay, and I'm doing the best I can. I'm going to do the same thing with this one here. We come right at the beginning. We're going to draw a straight line down to this point here. This one here, since it is the fastest, this is the P wave, and this is the S wave. Now, what we want to do in order to find the earthquake, we have to find the difference between the two. So if we come down here, and I know this is 8:07, halfway here is going to be 30 seconds. So I know this one right here is going to be this one took place at 8:07, and we're going to say about 30 seconds. Now we need to know what time the S wave occurred. Well, we come down here, we know it was 8:09, and it's about 30 seconds into this. So, or 8, this is 8:10, 8:11. So this one took place at, the S wave hit at 8:11:30. So at the 8th hour, 11 minutes, 30 seconds. And we can do these for each one of these. So we can actually find these 3 locations. We come down here, we're going to do the same thing, draw a line down, try to make them as perpendicular as you can. And I'm just going to go ahead and fill in all of these. Come down here to Honolulu. I want to try to do the same here, and sorry, my lines are getting all smudged, but I should still be able to do this. This one is about half. I'm going to still say it's halfway. So this one takes place at 8:08:30. So 8th hour, 8 minutes, and 30 seconds. And this one was 8:07. It's got a little bit smudged. S wave. And this one ended at 8:11:30, or 8:13:30. Sorry, I keep getting that backwards. 8:13:30. Okay, and the one at Honolulu, so that was Charlotte. The one at Honolulu, we're going to say is 8:09. So we have 8:09, and we're not quite half, so let's say that we're about 0.25. So about 25 seconds. And the S wave hit here about 8, so we have the 8, 14, 15, and then the seconds, we're going to say about 15 seconds. Okay, so I have all of my P wave times, and I have all my S wave times. Now, in order for us to use this chart right here, way, if you remember this, I have to find the difference between the P and the S wave. And that's really easy. So this one, it was, I'm going to actually put this right here. This might actually help out a little bit better, so you can see it a little bit better. So we're going to say that this first one started, the P wave was at 8:07:25, and the S wave was at 8, oh wait, we said 30, 8:11:30, and if we subtract the difference between the two, we are going to get 4 minutes. So there's a 4-minute space and time between the two waves. That would be Sitka, so Sitka is 4 minutes. We go to Charlotte and we have 8:08:30, and we're going to minus that from 8 right here, 13:30, and if we subtract the 2 there, we're going to end up with 5 minutes. And if we come down here to Honolulu, we see the P wave hit at 8:09:25, and we're going to subtract 8:15:15, and we are going to get about, I'm just going to round this because it's just a little over 6 minutes, but we're just going to say 6 minutes. Just keep it simple here. Now if I was to really do this and it was really had to be accurate because we really wanted to find out what this is, then we have to make sure that we've got everything exactly the way it is. So I know that Sitka has a time difference of 4 minutes between the P and the S wave. Charlotte has a difference of 5 minutes between the P and the S wave, and Honolulu has a difference of 6 minutes between the P and the S wave. Now this becomes important because we're going to use that information to be able to identify where our earthquakes actually are located. Okay, so I have another map here we're going to use. We're going to pull this out of the way. Okay, so we're going to go ahead and take a look at this. So I showed you before here just how to be able to pick up the times, and that is from the P wave and the S wave, and you look at the two marks on that seismograph, and then you take the difference. Now this, I have already done this, so we're just going to kind of show you a few things here. So if you can see right here, and to those of you who might be complaining about all of these times being 5 o'clock, I know they're all 5 o'clock. I know they wouldn't all be 5 o'clock because they're all over the country all at the same time, but we're just trying to make things simple and try to help you to understand what we're doing. So the first one is the P wave time, and the second one is the S wave time. And so what we're going to do is we're going to subtract the difference here. So the difference here is 2:10. This one's at 5, this one's at 5:04:40, so the difference is 4 minutes and 40 seconds. Do the same thing here. This is 3 minutes and 40 seconds. 2 minutes, 30 seconds, and 1 minute and 15 seconds. Okay, so now that we have these times, what we want to do now is we want to actually look at what the distances are. This is where we are going to bring in this graph right here, if you remember. Okay, so I'm going to put this just right off to the side. I'm going to bring this up here. So we know what the difference is in time. So this first one is 2 minutes and 10 seconds. So what I'm going to do, I'm just going to take a piece of paper here and I'm going to mark it right here. And I know that this point right here is my 0, and this, let's do this. Let me bring this out here. There is 1 minute, and here is 2 minutes, and then I have 2 minutes and 10 seconds. So I'm going to make a mark about right there. Now, if you remember, we're going to take this and we're going to line up till we have a mark here and a mark there, and we're touching both. So we are about right to there. And then we come down here and we draw. We can either draw a line or we can just, hopefully you can see this, and just make a mark right there. Okay. And this right here, okay, so we're looking about halfway. That should be about 12, I think. 1,200 kilometers, is that right? I think that is correct. So, what is our distance here? We've got 1,200 kilometers. Okay, now we'll go to our next one here. So our next one is 4 minutes and 40 seconds. So we're going to do this again. It looks like 4 minutes and 40 seconds is putting us, there's 4 minutes, there's 30, 40, probably about right there. Okay, so we're going to put this right down here, and I'm going to put a mark about right there. That would be 4 minutes and 40 seconds. Now what I'm going to do is I'm looking for a gap here that would meet both of these. About right there. About. Okay. I've got my ruler here. I'm going to just go ahead and put a mark down here. All the way down. Okay. And that should be what? About halfway, so we're what, 20, maybe about 29, about halfway. These are in increments of 4, so that would be 28, 29, yeah, 29, so maybe like 2,900 kilometers, so in kilometers. And our next one is 340, so we're going to do the same thing again. I'm going to come up here, this is 340, is about right there, so I'm going to take this, I'm going to put a mark right here, and I'm going to come up here and find out where 340 is, which is probably about right there. And I'm going to make a mark right down along here. Okay. So now I have this mark right here, about halfway. That would put me about 2,000. So 21. Yeah, maybe 21. Yeah. Let's go on. Maybe let's go 22. 2,200 kilometers. Okay, so now I have 2 minutes and 30 seconds, so that's going to be half. So I'm going to go ahead and mark right here. That puts me about right to there. 2 minutes and 30 seconds. About right there. You can see this. Okay. And we're going to put a mark right down here. And where does that put us here? So we're going to mark here. And that's going to be, what, 1,200? So maybe like 13? Yeah, maybe like 13. 13, 4, let's go 1300. Okay, and then we have one more, 1 minute and 15 seconds. So, here we go. Come up here. I find my 1 minute mark and 15 seconds. I'm just going to put that about right there. And if we come down maybe about right to here, draw straight as possible. Okay, so we have our mark right here, and I'm going to say that's about 600. So we have 600 here. Okay, so we've used this chart. We filled out all of our distances. We have all of the distances right here. So 12, we can see that Rockville is about 1200, Newport, Washington 29, Arizona 22, Rapid City is 13, and McMinnville is 600. Now we only need 3 places, but we're just gonna, the more places we can get, the better off we'll be. So I've put this little chart right here, and what we're going to do is we're going to go to our first place, which is Rockville, and we know we're at 1200. So if you see, there's 1200 right there. These are in hundreds. So that's 300, 600, 900, 1200. So I'm just going to put a mark right here. And I'm going to come all the way to my 12. Like that. Okay, and hopefully this will work, right? So we're going to put this about right there. And we are, what we do is we just draw a circle around. And that is 1200. Now we go to Newport, Washington, and that's like 2900. So that's going to bring us all the way out here. So I'm going to bring it all the way out to here, to the 29, and mark it there. And we're going to go out here to Newport. I'm going to put a dot right in the center. And we're going to go ahead and make a mark here. Hopefully this will work. That's a pretty big mark. Okay, so now it's saying that the earthquake is either right here or right here. Because Newport's saying that it happened somewhere along this line. Rockville is saying it happened somewhere on this line, and where the two cross, we know that that is it. So really, we can take any of those, and it will probably give us where we need to be. So let's go to Arizona. We know that we're 22. So let's put our mark here, and we're going to come over about 22. Okay, and we're going to go to Arizona here, put in our center, and if we did this right, it should give us pretty close. Okay, it's a little off. I should double check that. Maybe it moved. Okay, looks like I moved it just a bit. There we go. So there's my mark right there. It's not this one. And these won't always be perfect unless you're absolutely precise, but it does work. So already we can see where that point is. We have this mark that comes up here, this one comes down here, so we can see that it's right here. But let's go ahead and finish the rest of them. So we have Rapid City, we're at 1300. So I'm going to make a mark right here. I'm going to take my compass and we're going to move that in here about to there. Rapid City, we're going to put a mark right here in the middle. Okay, and we should be able to make a mark, so we come right through here. And that's pretty close. And then we can do the same thing with McMinnville, which is 600. So we're going to bring that right here, bring it down to the 6. Touch that, and McMinnville. Okay. Alright. Let me come around. Alright, you can see. So we have a pretty good idea where that earthquake took place. We can see that it took place right here. Okay, and this is what is called a triangulation. We know that we have to have, right here, we have to have at least 3 points to be able to identify where the earthquake is. Okay, so hopefully this helps. We can find the epicenter. We can find out, and there's a lot more we can actually find. We can find out what time that these actually took place. There's a lot of other information, but this should do it. Hopefully this will help you to understand a few little things about triangulation, and so when you do this final, you'll be okay. All right, well, good luck.